In this video, I wanted to introduce polynomials and a couple of the terms that we need to know. So a polynomial is defined as an algebraic expression in the form p of x equals a n x to the n plus a n minus 1 x to the n minus 1 and so on all the way down until we've just got an x term and a constant term on the end, so just a number. Now n is always a positive integer for polynomials. So in that definition, we've got a few terms that we need to know. So our an, our an minus 1, and so on, they're all called coefficients, and they're just numbers that are in front of our x terms. An, x to the n, is called the leading term, and an is called the leading coefficient. A to the 0, so that one on the end that doesn't have any x's with it, that's called our constant term. If a to the n equals 1, so that first coefficient in front of the highest power of x is just 1, then it's called a monic polynomial. And the last one is the order of the polynomial is n, so that highest power. We can also say that the polynomial is of degree n. So for example, we've got two polynomials written down the bottom here. In this first one, this polynomial is of degree 6 because that's our highest power. The coefficient of that highest power of x is just 1, so it's a monic polynomial. The constant term is 3. In this second one, it's a polynomial of degree 3 because that's the highest power of x. It's not monic because the coefficient of that highest power isn't 1. That's our leading term there, is that whole half x to the power of 3. The leading coefficient is that 1/2. And the constant term is that minus 2, so not just the 2 on the end, but the minus 2. Our next two expressions are examples of things that aren't polynomials. And the reason they aren't is because some of the powers aren't integers, they're not whole numbers. So for example, in this one we've got x to the power of 1/2, and in this one we've got that x in the denominator. If we brought that up so it wasn't in the denominator anymore, it'd be 4x to the power of minus 1. So again, it has to be a positive integer for it to be a polynomial. Now, if we have a polynomial expression that's equal to 0, that's called a polynomial equation. Now, the values of x that satisfy that equation are called the roots or the zeros of the polynomial. So for example, if we're asked to find the zeros of the polynomial x squared minus 4x, to find that we're going to set this expression equal to 0. So we're setting p of x equal to 0. So we would have x squared minus 4x equal to 0. To solve this, we're going to factorize. And we always look for common factors if we're trying to factorize. So these have a common factor of x, so we'll pull that out the front. We'll have x outside of x minus 4 equals 0. Now the only way that that can happen is if one of these things is equal to 0. So we either have x equals 0 or x minus 4 equals 0, which would mean that x equals 4. So those true values are the zeros or roots of that polynomial equation. Our second example asks us to find the roots of the polynomial x squared plus 2x minus 15 equals 0. So we've already got it written as an equation equal to 0, and now we need to factorize it. There's a couple of different methods for factorizing quadratics, and if you've got a different one to this, that's fine, you can use it. But if we look at the PSF method, we need to find two numbers that multiply to give minus 15, that add to give 2, and those two numbers would be 5 and 3, but one of them is going to have to be negative. Now if we want it to be a minus 15, one of them has to be negative. If we want it to be a positive 2, it's going to have to be a positive 5 and a minus 3. So that means that this is going to factorize to x plus 5, x minus 3 equals 0. And then it has to be one of those brackets is equal to 0. So x plus 5 equals 0, x minus 3 equals 0, and then solve each of those. So the roots of our equation are x equals minus 5 and x equals 3. So it's a quick introduction to polynomials.